In this module, we're talking about normalization, one of the most important topics in data analysis for genomics. And we're going to use some real data to motivate the need for normalization and then explain 3 different approaches to doing it. Okay, so here is a plot of 5 replicated arrays. These are RNA gene expression arrays. You get very similar plots when you use RNA-seq or data from other applications. So we created replicates and we put it on 5 different arrays. Then I'm showing you a box plot of the log intensities. So you can see that they're shifting. You can see, for example, that the first and the second one have on average, the first one is almost twice as large. So if we were to interpret this directly, we would think the sample that was hybridized to this array has twice as much gene expression overall as the second one. But we know that's not the case because these are all replicated samples. Now the problem is a little bit more complicated than just shifts. We also see differences in the distribution. So this is now the same data, the same 5 arrays, but I'm showing you a smooth histogram, and you can see that there's changes in the distribution. For example, this green curve has a larger bump than the light green one. So here is another plot that's showing a further complication with the data before it's normalized. So this is an MA plot on the left of 2 of these 5 arrays. And we can see that there is a nonlinear effect. In the left side of the plot, we see that the average difference is close to 0, but as we move along to the right, then the average difference starts dropping close to 1, a full change of 2. On the right, we see the 2 densities, and we can see that they're quite different. The green one doesn't have this second bump. So a naive approach is to simply adjust the medians of the data so that the medians match. But note that if we do that here, all we would do is shift the data up, but we would not remove this nonlinearity, and we would not fix the problem that the distributions are different. And just to reiterate, these are technical replicates. This is the same RNA hybridized to 5 different microarrays. Now, here's a plot showing you how the problem could have effects downstream. So now we're using data from the spiking experiment, which we used in previous modules. So I'm showing you the comparison of 2 arrays from the spiking experiment, where the black dots represent data from genes that are not supposed to be different, and the green dots show you data from probes that are supposed to be different. So what we see is that the green dots, at least these green dots over on the right, are in fact appear to be different. If we interpreted the data just as it comes to us, we would have all these points here. There's hundreds of points there that have fold changes just as big as all these green points. That's the problem. And that's why we need to normalize, and that's why simple approaches like shifting the mean don't always work. So in today's module, we're going to show you 3 different approaches that have been very successful in microarray data and are starting to be used in other applications such as RNA-seq.